In this question, the rate of the chemical reaction doubles for an increase of 10 Kelvin in absolute temperature from 298 Kelvin. Calculate the value of EA. EA is the activation energy. So here in this question, it is given that when the temperature increased by 10 Kelvin, then the rate becomes double. So here it means that when the temperature is increasing, we can say that rate constant also increases because temperature and rate constant are directly proportional. And we know that when the temperature is increasing, it means that rate is also increasing. So here we can conclude that. So from here we can say that rate is directly proportional to the rate constant when we consider the factor as a temperature. This is not applied for concentration, it is only applied for temperature. So now in the question, it is given that T1 temperature is 298 Kelvin and the T2 will be increase of 10 Kelvin. So 298 Kelvin plus 10 Kelvin is 308 Kelvin. Now temperature T1 and T2 is known, and here we can assume that the rate constant K1 is equal to K. So the K2 will be 2 times of K because the rate becomes double. So when the rate is double, so K is also double. Fine. So now we can use the formula log K2 by K1 is equal to EA divided by 2.303 into R T2 minus T1 by T1 into T2. So if you substitute the value, log K2 is equal to 2K divided by K is equal to EA divided by 2.303. This R is a gas constant and we take 8.314 value. T2 is 308, T1 is 298 divided by 308 into 298. Further solving, this K and K gets cancelled. So log 2 is equal to EA divided by 2.303 into 8.314 into 10 divided by 308 into 298. So log 2 value is 0.301 EA into 10 divided by this whole value, we can write it as 1.757 into 10 to the power 7. So this 10 and 10 to the power 7 will get cancelled. So we can write EA is equal to 0.301 into 1.757 into 10 to the power 6. So EA will be equal to 52.9 kilojoule. So this is the answer of this question.